Hello and welcome. My name is Tabitha Odom. I'm the chair of the EMVCo 3D Secure Working Group, and this is a pre-recorded presentation providing an update on EMV 3D Secure. Let's begin by taking a look at the EMV 3D Secure initiative. There are three key points I like to call out when it comes to the initiative. What is it? Why, and what role does EMVCo play? What is it? It's a tool, a specification that allows authentication to occur between the issuers and the cardholder before transaction authorization. The why is the opportunity that we have for remote commerce as a growing segment to have transactions that are occurring on multiple platforms be able to take advantage of this protocol for authentication. And what role does EMVCo play? The role EMVCo plays is to enhance and maintain the specification, this protocol, based on industry feedback. Now let's look at the role EMV 3DS plays in the remote commerce or e-commerce industry, which is continuing to grow worldwide and with multiple and various devices, where a high degree of fraud and friction exists. EMV 3D Secure, or 3DS as it's also known, is a messaging protocol that promotes an improved consumer experience when making e-commerce purchases by enabling intelligent risk-based decisioning. The exchange of 3DS data between the merchant and the card issuer reduces fraudulent use of online credit and debit transactions by preventing unauthorized use of cards online and protecting merchants from exposure to fraud-related chargebacks. In a nutshell, 3DS provides a secure communication channel between the cardholder, merchant, and issuer, supports secure identification of the cardholder and the online transaction, and enables the issuer to authenticate their cardholder before a transaction authorization. Now let's go a little bit deeper to understand more about the EMV 3DS protocol. So the overview of 3DS is 3DS stands for 3 domain secure. And again, it's that messaging protocol for use of authentication of consumers during online shopping. The 3 domains consist of the merchant acquirer domain, the interoperability domain, and the issuer domain, and the exchange of messages between all of these domains. The 3D Secure messaging protocol was originally created by Visa in 2001 and licensed to other payment systems. The original version is still owned by Visa, known as version 1.0.2. In 2015, EMVCo announced that it would advance the next generation of 3D Secure, and collaboratively, the members of EMVCo, guided by feedback from the industry, created the next major version of 3D Secure, now known as EMV 3D Secure. The purpose, again, is to facilitate the exchange of this data between stakeholders, the merchant, cardholder, and card issuer. The objective is for each of these parties to benefit by providing the ability to authenticate cardholders during an online card not present purchase, reducing the likelihood of fraudulent usage of payment cards. The benefits include additional security that is aimed to reduce the fraudulent use of the credit and debit transactions, prevent the use of unauthorized cards online, protect the merchant from exposure to fraud-related chargebacks. 3DS has been adopted by many payment systems as a foundation to build their proprietary products. For example, you may be familiar with Verified by Visa, MasterCard Secure Code, J-Secure, or American Express SafeKey. Now let's take a look at the features of EMV 3DS technology. Again, I'm calling out here that EMVCo's role is to maintain the EMV 3DS specifications, administer testing, and provide an approval process to support e-commerce transactions in a globally interoperable manner. The features of the specification include support for app-based purchases on mobile and other consumer devices, enhanced functionality that enables merchants to integrate the authentication process into their e-commerce checkout experiences for both app and browser-based implementations, use of multiple options for step-up authentication, such as one-time passcodes, biometrics, and out-of-band flows. We also added a non-payment message category to provide cardholder verification details to support various non-payment activities, such as adding a card to a wallet. There's also the flexibility to accommodate global and local needs. And importantly to point out is that the specification is available royalty-free from the EMVCo website. EMVCo will continue to enhance the 3DS specification based on feedback from the payments industry. Now I'd like to highlight other key benefits of EMV 3D Secure. The exchange of data between the merchant and the card issuer can increase authorization approval rates and reduce the risk of fraud, while at the same time optimizing the cardholder experience. Merchants are able to implement a consistent approach across multiple platforms and digital channels for cardholder authentication or account verification. EMV 3DS-based solutions can achieve this during the purchase process, minimizing the risk of potential checkout abandonment. It also protects the merchants from exposure to fraud-related chargebacks. We know that consumers seek increased convenience and security during e-commerce payments. Solutions based on the EMV 3DS specification maintain the existing online checkout experience. There is minimal to no impact on the applications and the payment flows that consumers are using and experiencing today. Issuers are able to increase the proportion of frictionless authentications due to richer data exchanges. By supporting new devices and channels, solutions compatible to the EMV 3DS specification will encourage cardholders to make purchases using their preferred medium without compromising on security. Next, we'll talk about the base construct for EMV 3D Secure. The 3DS authentication flow is symmetrical regardless of the payment channel or medium being used. For example, whether it's a mobile connected device or even the internet browser. Payment authentication, as you can see from the slide, is the foundation for EMV 3DS. Non-payment authentication builds upon the foundation created by payment authentication, and digital wallet borrows from both payment authentication and non-payment authentication. Digital wallet is still evolving as we look for ways to enhance the specs to support the digital wallet environment. Here we take a look at the use case example. You'll notice that the browser and mobile payment authentications are the same, giving credence to the symmetry regardless of the payment channel or medium being used. For non-payment authentication, you can use the EMV 3D Secure framework for cardholder verification to support activities such as adding a payment card to a digital wallet. Looking at the timeline that we've been working on since we started with the EMV 3D Secure specification, in October of 2016, we published the first release, which is 2.0.0. A year later, we published the 2.1.0 specification. And in June of 2018, the draft of version 2.2.0 was published. In August of 2018, the test platform launched to support version 2.1.0. And in December of 2018, version 2.2.0 of the specification published. And just recently, in mid-2019, the test platform launched to support version 2.2.0. So now let's take a look at EMV 3DS version 2.2.0. It builds upon the key benefits that existed in 2.1.0, with the main goals being to increase approval rates and reduce fraud. I'll touch on each of these key features as we go through. Promotion of frictionless authentication. We added enhancements to version 2.2.0 to offer options for fewer step-up authentication, while at the same time being in compliance with regulations such as PSD2 in Europe. There are now indicators for strong consumer authentication or transactional risk analysis that may have been performed prior to the authentication message being sent. There is now the ability for the merchant to send data as information only to the ACS or issuer. And there are indicators communicating if the cardholder has already whitelisted themselves to a merchant prior to the transaction or wish to whitelist themselves to the merchant during the transaction. I call out here that also we have built in additional support for FIDO authentication, token, and secure remote commerce. The specification has been updated to carry additional data from the merchant to the issuer for these specific areas. New authentication channels. There is now support for mail order, telephone order transactions known as MODO. You can now identify these transactions within version 2.2.0 with two key features: the addition of the 3DS requester initiated payment, so now allowing 3RI to be on the payment flow, a channel that allows the merchant to initiate the authentication request without the cardholder being in session. This channel has only supported non-payment transactions within version 2.1.0 for account verification purposes, but now the channel has been expanded to support MODO and recurring transactions where authentication may be required, but the cardholder is not in session. And then secondly, the addition of a new authentication method, which is decoupled authentication. This new method allows cardholder authentication to occur if the cardholder is offline. The authentication method can also be used if the cardholder is online via the browser and app channel. Now we'll discuss better communication across all domains. We made improvements to the EMV 3DS caching process, that is the PREC and PRES cycles. The PREC-PRES messages are utilized by the 3DS server to cache information about the protocol version numbers supported by the available ACSs, the DS, and also any URL to be used for the 3DS method call. Two key improvements were made in version 2.2.0 based on technical associate feedback. One, a new field, ACS information indicator, that allows the ACS to communicate which capabilities their account ranges support. These capabilities can include whitelisting or decoupled authentication. And then secondly, the ability for the DS to send only the modified data instead of the entire data load to the 3DS server during the caching process. There are also improvements made to the user interface and cardholder experience. Three key things to call out here: additional whitelisting data elements two of them, to allow whitelisting to occur on a single native screen. Those two elements are whitelisting data entry and whitelisting information text. Secondly, a new data element to allow the cardholders to seamlessly return to the merchant app after authentication on the issuer's authentication app for out-of-band transactions, and that's enabling the 3DS requester app URL. And then third, the ability for the SDK to launch the CREX automatically to generate the final checkout page. This change eliminates the need to press the continue button for out-of-band transactions when they are occurring on the same device. And lastly, identification and verification. What remains unchanged in 2.2.0 is this feature. We expect this to have a larger focus in the next year or two as EMVCo better understands how customers want to use the 3DS specification for less traditional non-payment use cases. We'll go into a few more features of 2.2.0. We felt it important to call out Requirement 311. Requirement 311 discusses the message version number and what protocol versions can be processed. The 3D Secure messages containing an active message version number supported by the 3D Secure component shall be processed according to the requirements of the specified protocol version. So this table 1.5, points out the protocol version numbers that are active or deprecated. If they are active, then the expectation is that there is support for processing that active version. Moving on to requirement 386, this was originally a version 2.2.0 requirement, but it was determined that it can be supported with version 2.1.0. This requirement checks whether the SDK device information data version is recognized, and if it's not recognized, the ACS proceeds with processing the transaction and does not error due to the unrecognized data version. As we enhance these specifications, we are also, of course, enhancing the device information document, which contains a data version number. When the SDK device information document publishes with a new data version, that SDK data version can be used for either the EMV 3DS version 2.1.0 protocol or the version 2.2.0 protocol. I discussed previously that we do have now support for whitelisting in version 2.2.0 of the specification. This key feature allows whitelisting to occur during the transaction and promotes frictionless authentication after the cardholder has whitelisted themselves to the merchant. The specification definition of whitelisting is the process of an ACS enabling the cardholder to place the 3DS requester on their trusted beneficiaries list. Take a look at the user experience with whitelisting strong consumer authentication occurring. In the AREC-ARES flow, in the very left-hand image, you have a purchase happening online, and there is a checkout that starts to happen in the second screen. In the third screen, you'll see the flow of the CREX-CRES starting to occur with a challenge occurring. But what you'll notice is at the bottom of the screen, there is a question for whether you would like to add this merchant to your whitelist, yes or no. If the consumer agrees to add the merchant to the whitelist, they simply select the yes button and continue with their checkout process. The checkout continues, the checkout is complete, and then what will happen on the next purchase, after whitelisting, it should become frictionless. So now you'll see that there's not a challenge happening. This merchant has been whitelisted by this consumer, and the checkout process is frictionless. You should note that the ACS always has the final decision as to whether strong consumer authentication is required for the cardholder transaction. Talk a little bit more about the whitelisting support. I'll take you through it through the various flows of 3D secure messaging. In the AREC-ARES cycle, the merchant can convey to the issuer that a whitelist challenge is acceptable via the use of the 3DS requester challenge indicator with a value of 0.9. The merchant can also indicate that challenge may not be needed as the individual was whitelisted in past transactions via the use of the 3DS requester challenge indicator, value 0.8. And the merchant can request whitelisting status update via a 3RI NPA using the 3RI indicator with a value of 10. The merchant can also indicate whether they believe the cardholder belongs to their whitelist using the whitelist status element. Issuers can provide a response back regarding whitelist status with the values presented here. For example, Y, 3DS requester is whitelisted by the cardholder, N, 3DS requester is not whitelisted by the cardholder, or maybe even P, pending confirmation by the cardholder, or possibly a U, where whitelist status is unknown, unavailable, or does not apply. And there is also a new data element of whitelist status source to indicate where the whitelist status source is coming from, whether that's the 3DS server, the DS, or the ACS providing this information. Continuing on to the CREC-CRES cycle, two new data elements were added to allow whitelisting to occur via a single page for a native in-app transaction. The whitelisting data entry, which is the indicator provided by the SDK to the ACS to confirm whether whitelisting was opted by the cardholder, and the whitelisting information text, which is text provided by the ACS or issuer to the cardholder during a whitelisting transaction. For example, would you like to add this merchant to your whitelist? This is now available in a single page for a native in-app transaction. In the AREC-ARES cycle, the ACS can send the DS and 3DS server the final whitelist status and source. Additional indicators can be used in the AREC message, similar to what was described in the previous slide. The values presented here to indicate whether a whitelist 3DS requester is whitelisted, is not whitelisted, or maybe even whether that status is unknown. The ACS will also send the transaction status and authentication value, assuming it was a payment transaction. And finally, within the PREC-PRES cycle, we talked earlier about the new indicator, ACS information indicator, that provides additional information to the 3DS server on what is supported by the ACS or DS. Whitelisting with a value of 0.4 can be indicated as supported by the ACS through this new element. Another key feature to discuss is the acquirer exemptions. This allows merchants to further seek a frictionless consumer checkout experience and increase the likelihood of approval during authorization. New values were added in the 3DS requester challenge indicator from the merchant, mainly during the AREC-ARES cycle. And these new values for the 3DS requester challenge indicator are 0.5, no challenge requested, transactional risk analysis is already performed, 0.6, no challenge requested, this is a data share only, or 0.7, no challenge requested, because strong consumer authentication is already performed. There's also a new value in the transaction status from the issuer. And this is the value of I, which means informational only, meaning the 3DS requester challenge preference was acknowledged. As discussed previously, also there is support for FIDO within version 2.2.0 enhanced support. To further promote the frictionless authentication experience, updates included expanding the 3DS requester authentication information data element to 20,000 characters and including a new data element called 3DS requester authentication method verification indicator. We are looking at other use cases that could further support frictionless, and we are in discussion with FIDO Alliance on those use cases. Key feature number 4 is the new authentication channel of mail order and telephone order via 3RR payments. To summarize this a little bit better, the EMV 3DS 2.2.0 will support 3DS requested initiated payments. Those 3RR payments can be utilized for modal as well as other cases. The preferred authentication method is still risk-based analysis, frictionless. If the cardholder challenge is required, both the 3DS server and the ATS must agree to using decoupled authentication as the authentication method. New data elements within the specification include the decoupled authentication indicator. The 3DS requester decoupled request indicator allows the merchant to indicate that they support decoupled authentication if required, but can still specify frictionless as preferred. A new value in the PRES within the ATS information indicator to specify which account ranges support decoupled authentication. Improved user experiences for out-of-band transactions, where out-of-band authentication occurs on the same device as the merchant app. The following improvements were included. The cardholder is automatically returned to the merchant app when authentication is complete on the out-of-band app. When the cardholder is returned to the merchant app, the cardholder is not required to press the continue button. So you can see in the images on the right-hand side that you're automatically switched to the out-of-band app and it automatically calls back the merchant app. No cardholder action is required as the SDK auto submits the CREC. And just one last thing on the key features for 2.2.0 and the improved user experience for out-of-band transactions. There were specification updates, of course, to support these improvements. A new data element of 3DS requester app URL allows that communication between the out-of-band app to automatically call back to the 3DS requester app. A new SDK requirement where the SDK automatically submits the CREC to the ATS when the merchant app comes to the foreground. This removes the need for the cardholder to click the continue button. And we removed the data element ACS HTML refresh and challenge additional information text, as these are no longer required to update the instructions with the above improvement. To quickly touch on EMV 3DS 2.3.0, I'll tell you about the focus for 2.3.0. 4 major priorities for 2.3.0 are enhance the user experience on gaming consoles and other smart devices, support additional FIDO Alliance use cases, further define the integration with SRC, and further enhance the out-of-band flow. That does complete my review update of EMV 3D Secure. I'd like to call out that this is a pre-recorded presentation and there are other pre-recorded presentations already available on the EMVCo website. EMVCo is increasing its outreach and information sharing through the use of pre-recorded presentations. Please watch them on the EMVCo website on the link at the bottom of the screen. Thank you. And for any other information or more information, please go to the EMVCo website at www.emvco.com or join us on LinkedIn. Thank you very much.